Hello everyone. In this video, we are going to learn how to plot a linear graph using the gradient and the y-intercept. More specifically, we will look at what gradient and y-intercept are, how to identify them from an equation, how to plot 2 points using the gradient and the y-intercept, and finally, how to draw the straight line graph. Let's start. In this video, we will look at different types of linear equations. Some equations will be written with y as the subject. Some equations will be written in standard form. And then we will also look at two special cases, one equation with only y and one equation with only x. These are the steps we will follow. First, we rearrange the equation to make y the subject if needed. Then we identify and plot the y-intercept. After that, we identify the gradient. Then we use the gradient to plot a second point. And finally, we draw the straight line graph. Before we start with the examples, we need to understand what the gradient and the y-intercept are. We usually write the equation of a straight line as y is equal to mx plus c. This is the form we need if we want to identify the gradient and the y-intercept directly from the equation. So, if the equation is not written with y as the subject, we must rearrange it first. In this form, there are two important parts. The first one is c. C is the number on its own, also called the constant term. This value gives us the y-intercept. Very important, when we identify c, we must take the sign as well, not just the number. So, if the equation is y is equal to 2x minus 1, then c is negative 1, not 1. The y-intercept is the point where the line crosses the y-axis. Since this point is on the y-axis, its x-coordinate is always 0, and its y-coordinate is always c. So the y-intercept has coordinates 0, c. Now let's look at m. M is the gradient. It is the coefficient of x. Again, when we identify m, we must take the sign as well. The gradient tells us how steep the line is, and it is defined as rise over run. The rise tells us how much we move vertically. If the rise is positive, we move upwards. If the rise is negative, we move downwards. The run tells us how much we move horizontally. If the run is positive, we move to the right. If the run is negative, we move to the left. This follows the positive and negative directions of the axis. So, starting from the y-intercept, the gradient tells us how much to move up or down, and how much to move right or left. This allows us to plot a second point on the line, and once we have 2 points, we can draw the straight line through them. This is because through 2 points, there is one and only one straight line. Now let's apply this to the first example. Plot the graph of y is equal to 1/3 x minus 1. The equation is already written with y as the subject in the form y is equal to mx plus c, so we can identify the y-intercept and the gradient directly. Let's start with the y-intercept. The y-intercept has coordinates 0, c. Here, c is negative 1. So the y-intercept is the point 0, negative 1. We plot this point on the graph. Now we identify the gradient. The gradient m is 1/3. Remember, gradient means rise over run. So 1/3 means that the rise is 1 and the run is 3. Since the rise is positive, we move 1 unit up. Since the run is positive, we move 3 units to the right. Starting from the point 0, negative 1, we move up 1 and then right 3. This gives us a second point on the line. Now we have 2 points, and since only one straight line passes through 2 given points, we can draw the straight line through them. This is the graph of y is equal to 1/3 x minus 1. Now let's look at example 2. Plot the graph of y is equal to negative 2 x minus 5. This equation is already written with y as the subject in the form y is equal to mx plus c. So we can identify the y-intercept and the gradient directly. In this example, we need to be careful with the signs because both m and c are negative. Let's start with the y-intercept. The y-intercept has coordinates 0, c. Here, c is negative 5. So the y-intercept is the point 0, negative 5. Be careful, the y-intercept is not 0, 5. It is 0, negative 5 because the sign is part of the value. We plot this point on the graph. Now we identify the gradient. The gradient, m, is negative 2. Again, the sign is important. The gradient is negative 2, not positive 2. Remember that gradient means rise over run. But here we only have negative 2. When we have an integer, we can always turn it into a fraction by adding a denominator out of 1. So negative 2 can be written as negative 2 over 1. This means the rise is negative 2 and the run is positive 1. So from the y-intercept, we would move down 2 and write 1. But here, we do not have enough space to move down on the graph. So what can we do? We can rewrite the same gradient in an equivalent way. Negative 2 over 1 is the same as 2 over negative 1. This is because negative 2 divided by 1 gives negative 2, and 2 divided by negative 1 also gives negative 2. So, when the gradient is negative, we can place the negative sign either in the numerator or in the denominator. The important thing is that we only place the negative sign in one of them. If both the numerator and the denominator were negative, the gradient would become positive. So now we can use 2 over negative 1. This means the rise is positive 2, and the run is negative 1. So, starting from the point 0, negative 5, we move up 2 and then left 1. This gives us a second point on the line. Now we have 2 points, so we can draw the straight line through them. This is the graph of y is equal to negative 2x minus 5. A quick check, the gradient is negative, so the line should go down as we move from left to right. And it does, so the graph makes sense. Now let's look at example 3. Plot the graph of 6x minus 2y is equal to 4. This time, the equation of the line is written in standard form, so y is not the subject. Before we can identify the gradient and the y-intercept, we need to rearrange the equation and make y the subject. To do that, we first move 6x to the right-hand side by subtracting 6x from both sides. This gives negative 2y is equal to negative 6x plus 4. Then we divide everything by negative 2. So we get y is equal to 3x minus 2. Now the equation is in the form y is equal to mx plus c. So we can work with the gradient and the y-intercept. The y-intercept is the point 0, c. Here, c is negative 2. So the y-intercept is the point 0, negative 2. We plot this point on the graph. Now let's look at the gradient. The gradient m is 3. Since 3 is an integer, we write it as 3 over 1. This means we move 3 units up and 1 unit to the right. So, starting from 0, negative 2, we move up 3 and write 1. This gives us a second point. Now, suppose we did not have enough space on the graph to move up and right. Could we find another point instead? Yes, we can. The gradient 3 over 1 is positive. A positive fraction can also be written with 2 negative signs. Negative 3 over negative 1. This is still positive 3 because a negative divided by a negative gives a positive. So that instead of moving up 3 and right 1, we could move down 3 and left 1. Both movements give points on the same straight line. This is useful when the graph does not give us enough space in one direction. In this example, we already have enough information. We have the y-intercept and another point, so we draw the straight line through the points. This is the graph of 6x minus 2y is equal to 4. Now let's move to example 4. Plot the graph of x plus 5y is equal to 15. This one is for you to try. Pause the video now, use the same method, and then press play to check the solution. Let's go through it. This equation is written in standard form, so y is not the subject. Before we can identify the gradient and the y-intercept, we need to rearrange the equation and make y the subject. To do that, we move x to the right-hand side by subtracting x from both sides. This gives 5y is equal to negative x plus 15. Then we divide every term by 5. Y is equal to negative 1/5 x plus 3. From this equation, c is 3. So the y-intercept is the point 0, 3. We plot this point on the graph. The gradient, m, is negative 1/5. We can write this as negative 1 over 5. This means the rise is negative 1 and the run is positive 5. So, from the y-intercept, we move 1 unit down and 5 units to the right. This gives us a second point on the line. Now we have 2 points, so we draw the straight line through them. This is the graph of x plus 5y is equal to 15. Let's look at another example. Plot the graph of y is equal to negative 1. So far, all the equations we have plotted had both an x term and a y term. This time, we only have y. There is no x term. Let's see how we can plot the graph of this line. Let's compare this with the general equation. Y is equal to mx plus c. Here, c is negative 1. So the y-intercept is 0, negative 1. We plot this point. Now, what is the gradient? Since there is no x term, this means the coefficient of x is 0. So we can think of the equation as y is equal to 0, x minus 1. The term 0x disappears because 0 times x is 0, so we are left with y is equal to -1. This means the gradient is 0, and when the gradient is 0, the line does not go up and it does not go down. So the line is horizontal. We already know that the line passes through 0, -1. So we draw a horizontal line through that point. This is the graph of y is equal to -1. Whenever you have an equation in the form y is equal to a number, the graph is always a horizontal line. Let's look at one final example. Plot the graph of x is equal to 4. In the previous example, we had an equation with only y. Here we have an equation with only x. So this is the other special case. To understand what happens, let's think about the general equation of a straight line. Y is equal to mx plus c. We said that m, the gradient, is defined as rise over run. In this case, x is always equal to 4. This means that when we move from one point on the line to another point on the line, the horizontal movement, the run, is 0. So the gradient would be rise divided by 0. But division by 0 is undefined. This means the gradient is undefined. In simple words, the equation x is equal to 4 means that every point on the line has x-coordinate equal to 4. That gives us the point 4, 0. But the graph is not just that one point. It also includes all the points directly above and directly below it, as long as the x-coordinate stays equal to 4. So the graph is a vertical line through x equals 4. This is the graph of x is equal to 4. So remember, every time we have an equation in the form x is equal to a number, the graph is a vertical line. And that is everything for this video. I hope this helped you. If you found it useful, leave a like and consider subscribing to the channel. Thank you for watching, and I'll see you in the next video.